Okay. Where's the video here? There we are. Okay. How can I see who's in here? All right. Well, I guess I'll go through some questions here. Let's go to page 240 in the review book. I can't even see who's watching right now, so I'm just going to start talking. Looking at 18 through 23. Mineral bubbles with acid, page 16 of the reference table. That's calcite. Number 2, very hard mineral with a curved, diagram 2 is a hard mineral with a curved fracture. That would lead me to believe that's quartz. All this is page 16 of the reference table. Let me be on here. Yeah. 23, colorless to white, cubic, that should be halite. 4, iron ore, red streak, hematite. 22, diagram 5, cleavage, flexible thin sheets, black, that is biotite. And 6 is a gray, cubic cleavage, ore of lead, that would be galena. All of that you would find on page 16 of your reference table. Everything there. And no one is asking questions, so I guess I'm just going to keep talking up. Can you show us how to do it on page 16? Sure, Christian. So page 16. So for example, the first one says it's colorless, mineral that bubbles with acid. You just look at the comments and you see calcite. Bubbles with acid, calcite. Number 3, salty, cubic, that will be halite. You're just reading the comments here. That's all you're doing. You're welcome, Christian. Moving on, 24. State the range of particle sizes of the sediments that formed rock layer C. So it's telling you rock layer C is a sandstone. So I go to page 7. I go to sandstone, and I see the range is 0.006 to 0.2 centimeters. That'd be 0.006 to 0.2 centimeters because it's telling me it is sandstone. 25, state 2 ways in which the composition of rock A differs from the composition of rock B. So A is limestone, B is shale. Limestone is bioclastic based on your reference table here. Shale is just regular clastic. Up here, bioclastic for limestone, meaning it was made of things that were alive. Another way the composition would differ, shale is made from clay-sized particles, really, really tiny particles, the smallest ones. Am I even on the right thing here? There we go. The smallest particles over there. for the side, and limestone is made from cemented shells and things like that. So anything like that is fine. 26, how would A have been formed? You could say compaction, cementation, weathering, erosion, anything that's on that rock cycle chart on page 6 leading to sedimentary rocks will be accepted there. 27, one reason you would choose a rock from layer A instead of C and D for a tombstone or statue. For the most part, A is softer, so it's easier to like carve your tombstone or your statue, because A is made of calcite, which is 3 out of 10 on your hardness scale, whereas usually your sandstone and conglomerates usually have a lot of quartz in them, which is a 7, which is harder. So it would just be harder to carve and stuff. Don't worry about that one. They don't really ask about that. State name of the sediment for rock unit B. It's telling you rock unit B is shale. I go to shale, and I would see that the sediment would be clay. I'm going to answer 29 and 30, then I'll see if you guys write any questions on that. 2 conditions that can result in metamorphosis: intense heat and pressure. A lot of heat, a lot of pressure. That's your 2 things. 30, if an igneous rock is composed of vesicular andesite, what are 3 types of minerals we can find in the sand weathered from that? So I just go to vesicular andesite. I go down to the minerals we'd find in there, and you can mention anything from plagioclase, feldspar, biotite, what's on the bottom there? Amphibole, and you can even include pyroxene in there. There's a tiny little bit. Vesicular andesite, minerals making it up. I'll wait a second and see if you guys write any questions about those. Let me see. Can't really tell if anyone in period 5 is actually in here. No one's writing anything. There's only 6 of you anyway. Let's see. Oh, Bianca Samade. Is there any rock cycle questions? Yes. I mean, if they ask how things are formed, that's rock cycle. Yes, Bianca, 35 multiple choice. Anything with a rock cycle, with how they're formed, just look here. That's it. Everything's right there for you. Let's see here. What else is decent here? Maybe page 242. Yes, on the lab practical, you'll have the reference table pages that would go with that thing. So, for example, rocks and minerals, they'll give you page 6, page 7, page 16. It'll be at the station already. Let's see here. Check in with period 5 again. Still nothing. Yeah. Let's see. All right. That's basically all I got. Any other questions? I'll wait a minute, see if you guys write anything. If not, I've had enough of this experience. Dave says, can you explain regional metamorphism? Yes. Basically, two tectonic plates coming together as such, and when they meet, you get intense heat and pressure where they form. So that's where you're going to have mountain ranges form. So if we have two plates coming together, they crunch up, and this would form the mountain range. So, for example, the Himalayas, that is where the Indian-Australian plate crashed into the Eurasian plate and created the Himalayas there. So you'll find any mountain ranges that you'll have metamorphic rocks in. So, for example, the Adirondacks upstate, that is where you would have regional metamorphism, rocks and minerals and things like that. So rocks that have already been made on your crust, they undergo intense heat and pressure where the two plates meet, and that is regional metamorphism, because it's a region is just a big area. Contact metamorphism, oppositely, that's when magma rises through the crust, and you get it'll look something like this. I lost the pages here. Contact metamorphism is always indicated by these little tick marks. So you'll see magma rising through the crust of layers that are already there. And because these are horizontal, we know they're sedimentary, along with the rock symbols. So this is magma rising up. So we have three types of rocks here. Magma is igneous. The sedimentary, it's already there. And where the igneous touches the sedimentary, you're kind of cooking them with a lot of heat, causing metamorphic rock to form along where those tick marks are. Was that helpful, Dave? Very good. Anyone else? Dave, please keep it nice. Sam Cruz, please. Okay, first off, how you're going to get to the test, I posted about that before, so go down and look at where I posted yesterday, March 23rd. It tells you exact. Nope, that's not it. Where's that thing I wrote about? Thought I wrote a thing about that. I'll write it again. To answer Bianca's question, how are we going to get the test? Tomorrow at 8 a.m., the test will open. You'll go into Clever. You'll sign into Clever. Click Castle Learning. I thought I wrote a whole thing about this. Guess I didn't. I'll make sure I do that. You'll go into Castle Learning, and you'll see my name or the class, and you'll click on it, and you can just go right to the quiz. You have an hour and a half for it, which is way too much time. I'll put up written instructions for you because I thought I did that. Sam Cruz, rock cycle in the reference table. Just see where the arrows go to. So igneous rock comes from magma solidifying. Anything melting leads to magma. So sedimentary rock melting leads to magma. Metamorphic melting leads to magma. All this is a cycle because you get all types of rocks from all other types of rocks. Once you have metamorphic rock weathering and eroding to sediment, then it can be compacted and cemented. Same thing with igneous rock weathering and erosion, or sedimentary rock weathering and erosion back to another sedimentary rock. Just a cycle. Lee Dubois. Different types of sedimentary rocks, chemical and clastic. Basically, clastic rocks are just pieces that are glued together through compaction and cementation. Chemical ones are the ones that evaporate out. So that's like rock salt and rock gypsum, where it used to be water, or it used to be covered in like some kind of ocean or sea. The water evaporates out and leaves behind the salt. That's a chemical sedimentary rock. Logan, the topics are rocks, minerals, rock cycle. That's it. Hope you guys went outside today. It's really nice. Okay. My roast will start at 6. Any other rock and mineral related questions? Okay. Well, that about does it. Good luck tomorrow. Godspeed. I'll be putting up instructions on how to do it in a few minutes. Bye. Logan, stop being weird.